All right, everyone. I'm Sam Charrington, founder of TWiML, and for this Solutions Guide Spotlight video, we're going to dig into Dataiku DSS with Christina Hsiao, who's a senior product marketing manager at the company. Christina, let's get started with some brief background. What is Dataiku?
Thanks, Sam. Hi, everyone. Dataiku is an end-to-end platform for data science and more broadly for, I guess, general data and analytics work. So everything from exploring and visualizing data to wrangling it and manipulating it for, let's say, business reporting or ETL, and of course, to delivery and development of machine learning pipelines and models. So that's Dataiku in a nutshell.
Awesome. And so we're going to be going through a demo. Tell us a little bit about the demo scenario that you've got lined up for us.
Sure. So today we're going to look at the use case of trying to predict flight delays, even though I know we haven't been in airports too much recently. Delays are something that can be predicted. So we'll take a look at how we blended historical data. We brought in real-time flight tracker information, weather data, all these types of sources to predict likelihood of a delay. And one of the things I'll show you kind of throughout is how you can work across that entire data lifecycle I mentioned, and in a collaborative way so that different people with different skill sets, technical skill sets, can all still work on the same project.
Great. Let's jump in. Where do we start?
All right. Well, we'll start on the home page. And so the home page of Dataiku is really the place where the team all gathers with their projects and shared projects. We have things like catalogs and shared code repositories, but for today, we're going to dive into that flights demo that I talked about. And so just to orient you to how to look at this project page, you can imagine this as the landing, like the command center for the project manager, for all the team members, for, analytic leads to come in and see, well, what's the project about? What are the objectives? What's the running to-do list? Who's working on the project and what have they done most recently over in the timeline, and some artifacts. So here's where we would jump off, and the real work happens in the flow. And actually the flow is a little bit more complicated than what I'm going to show you because we've got a lot of moving pieces, but I'm going to focus on this main part of the flow. And this is the pipeline we've built to predict those delays.
And so is working with the Dataiku product, is it primarily a visual experience?
It can be visual or it can be code-based. So what I'm going to show you today is primarily how you would use it if you want to go through the user interface. But when it comes to coding pieces, we do have really great support for coders. So they can work in the editors, either the Jupyter or the code editors here or in their own IDEs. And of course, for operationalization, everything needs to be done via API. So a lot of the actions you're going to see me do today with clicking can be done through the API as well.
Great. So what are we looking at here?
Well, what you're looking at here, you read it left to right, and I'll actually show you some of these tags to explain. We've brought in some data, historic flight data, airport weather information, things like that. The next little piece is preparing it and doing some feature creation, deriving new fields, enriching the data. And then we move into a modeling phase where we do that binary classification, that prediction, going to be late or not, coming out of New York. Spoiler alert, the answer is probably, if you have any luck like mine. And then deployment. So what do you do with it? How do we operationalize this, get it into the hands of users? So I can walk you through kind of a day in the life of maybe an analyst starting with the data, and then when they hand it off to the data scientist, what they do with it, and then maybe what an ops specialist would do to make sure this thing runs nicely in production.
All right, yeah, that sounds great. Let's do it.
Awesome. So connecting to data is the first step, always kind of a little tricky. Dataiku can connect to all different types of data storage systems. And in fact, this one doesn't even have that many. Here's another environment with a lot more connections set up. But you can see here, I can pull from cloud storage, on-prem databases, cloud databases, you name it. Once it comes into Dataiku, it all kind of looks like an Excel table on steroids, just rows and columns, very familiar.
Mhm.
And I can explore it. So, as I go through here and I look at this, I'm going to scroll across here. And you could say, well, let's just profile the data a little bit. I can build pretty charts too, but just on a column by column basis, let's see what these things look like, maybe the outliers and the stats. Let's take a look at some of the missing values and some of the cleanup work I'm going to have to do.
Okay.
So lots of ways to profile the data. You can see these quality bars help us find stuff that we have to fix, and chart statistics, lots more. But the first thing I would do is prepare it. And so to do that, again, I can use the visual point and click recipes, this whole tray of tools that are very common transformations, or I can code my own logic, say in Python.
Okay.
And so in this case, we'll crawl across the flow and we'll take a look at the prepare recipe, because this is one of the most powerful recipes in Dataiku. It's got about 90 plus processors. So everything you can think of that you would do in Python or in Excel or in any other kind of data wrangling tool, date handling, reshaping, some NLP stuff, handling arrays. And it gives me a little bit of a wizard to do that with lots of options. So for example, in this one, this is kind of simple, but we've taken the date and we've parsed it, and then we've created a floor to strip off the minutes. We just care about the hour of departure.
Got it.
And we used a custom formula, or we rounded values, or we reduced data through filtering. And so it's very to this purpose type processing in the prepare.
Got it. And do each of these steps show up as an individual block within the flow, or is this kind of a set of tasks under that prepare?
The second one. It's wrappered into this prepare recipe, and I can annotate each step, or I can annotate the recipe so that when somebody's back on the flow and they hover, it's like basic cleanup, whereas this one's enrichment.
Got it.
So it's good practice to keep the manipulation almost in little modular unit blocks so that somebody doesn't have to go through a really long list of everything all at once. You can kind of see filter, then aggregate, then join, then, et cetera.
I was going to ask, when we were looking at the flow and you pulled up the data sources, about the kind of deployment model, in the sense of, is this an enterprise style of solution where the assumption is that some other group manages the data sources and has set those up as kind of objects that live for me? Or do I, as an individual analyst or a data scientist, have the responsibility or ability to set up my own connections to data sources?
At the enterprise level, so when we're working with big companies who have data engineers who have existing ETL, the way it typically would go is, you have, let's say you have certain clusters, or you have certain S3 buckets that you're allowed to access, or certain permissions to databases. And those are set up for users so that they say, you log into this Postgres with your cred so that you only get access to the data you're allowed to see. We curate that data, but once it's in Dataiku, you can go and then transform it for your analytical purposes.
Okay.
So, the smaller you get, the less governance you have around data in general as a company, but usually we connect to existing infrastructure. We process in place whenever possible instead of streaming it through memory. And then it just lives all in that database.
Okay.
So if we come out here, we looked at a visual recipe, the prepare. You can see here, there's aggregations and really easy ways to do grouping. You just kind of choose the aggregation you want on the columns. You can rename your outputs. You hit run. You can run it in different engines, right? Using Spark, using Kubernetes, distributed. It all depends on really what your needs are.
Okay.
And let's take a look at a visual join. This is another really common one because it's really easy to get twisted around in the SQL. Visually, I can just choose the kind of join I want. A little reminder here for upskilling those citizen data scientists. Remember, the difference between inner and left and so forth. And with the GUI, I can change what the conditions are. Is it fuzzy? Is it exact? What are the fields that are going to match? What are the columns I want to bring in? And even if you are a coder, and plenty of coders, our power users do both, because if they do this or they convert to a SQL recipe, well, there's the query. And I didn't have to type it. I didn't make typos.
Got it. So it's not hidden from you. You can't access it. It's there when you want to go deeper.
Yep. The beauty of Dataiku is you're only ever about 2 steps away from code at any point customizing with code. So it's really extensible. And so if I'm just trying to bootstrap a query, a SQL query, this was a really fast way to do it, and then go off and modify the code.
Okay.
So in this flow, what's happening is I took that table that we prepared, we enriched it with a Python recipe, and let's look at some code recipes. We said, well, this one uses a dictionary that we built here, a library. Let's look at this one that's got more of the code built in. Here we go out to another site and we get information about each aircraft, thinking, okay, if we know how old the aircraft is, that might give us a warning of that there's going to be a maintenance delay, maybe. And so for those coders, we've got all the interactive Jupyter. As I mentioned, you can code at an IDE, make it really simple to do testing and change your code environment to bring in the packages you need, all that kind of stuff.
Mm-hmm. And what kind of integration is there with Git for folks that are coding directly?
Everything is Git integrated. So behind the scenes of this project, every save, every run I do is committed to a Git repo.
Okay.
But you can also connect notebooks to like remote repositories and push and pull. You can do cloning and branching and all that type of stuff.
Okay.
As well. So everything's Git friendly. If we go back to the flow, you can see in addition to the stuff we did to enrich it with code, we also use these window recipes to calculate, let's see, what does it say here? The average delay for each airport for the last 5 days. So has the airport been running behind recently? Has the flights before me been running behind? Those are all good indicators. Mm-hmm. So each of these little branches go on and they add more information and we join it all together.
Got it.
Make sense?
It does. I know one of the things that we're going to be talking about is AutoML. That is sometimes applied to the modeling process, but it's also sometimes applied to the data preparation process, identifying, likely feature engineering types of transformations for a given data set. Is any of this upfront work that you've done automatable through some kind of AutoML?
Well, so there's a couple ways to think about feature engineering. Yeah. One is the stuff that the subject matter expert knows they want, and maybe Dataiku gives augmented support to do that. So if you're trying to derive, let's say from a date, the day of week or the week of year, those are all kind of part of the augmented data prep that Dataiku will help with, but you have to know you want to apply it.
Okay.
The stuff that's more like, okay, create polynomial combinations or pairwise combinations by multiplying every numeric column by every other one, that gets handled in the AutoML part that I'll show you in a minute. So everything I've done this part is kind of like the subject matter feature engineering by hand with some help from Dataiku. And then as we move in.
Something like encoding categorical variables, is that automatically done thing or?
Yeah.
Okay.
Yeah, I'll show you. That would happen more in the modeling phase. And one other thing, I'm trying to think about which table it will be. I'm guessing this one. One of the most common things you would do is create charts on your data as you go to kind of understand it and know what types of clipping you should do or segmentation you should do as part of feature engineering. Before we model, we typically will run some statistics cards also. And this will help us understand, even before we go into the AutoML, which of my 5,000 columns might be the ones that actually have predictive power.
Okay.
So do a bivariate analysis or some fit curves and things like that. And this is running on a couple million records here. So let's see. This is one of the ways that I would immediately start to think about feature selection. Maybe a correlation matrix, for example, mm-hmm. or heat curves. So if I go back to my table, let's say we're all ready to model. And I want to do more feature engineering, more feature creation, and the pre-processing you talked about. I would go into the lab here, or I can actually even just go right over into my target variable here and say, create a prediction model in this case. If I wanted to do unsupervised, I could go to the lab and say, oh, let's do some clustering. But here's where the AutoML templates start to come in. And I can pick, am I in a regulated industry? It's more important that I have like regression versus random forest, right? The interpretable versus not. If I'm an expert and I want to code my own or do deep learning, I can go down these paths. And actually, let's just go look at the one that we built and kind of back into it. You can see here, this is all the versions of this model we've published. As we improve it, each time we have now one active version, but let's see how we built it. Over in design is where, Sam, what you asked about, we would handle that. So for example, features handling. Dataiku makes some assumptions based on what you've told it, like turn off really high cardinality values, turn off IDs, those aren't good, turn off long text fields, unless I really want to use them, right? And then do something different. But let's say carrier, it's categorical. Well, it's going to dummy encode it by default.
Okay.
If it's a numeric, it's going to automatically do standard rescaling, but I can do something different, or I compute different ways.
Okay.
So I have a lot of control. It's kind of like this best world of black box. I'm using algorithms that are pretty hard to understand for a human, but I have all this control over what am I optimizing for? What do I think is going to happen? I think early arrivals, if the last 3 flights were on time, my flight should be on time. If it's the first flight of the day, I think I should be on time. So I can make these assertions and have the model check it for me to make sure, it makes even just intuitive sense.
Got it. And the conditions that the assertions are based on is kind of any column, and you're just kind of building it up from conditions on top of the columns.
Yeah. So you might create profiles. Usually, the subject matter experts who work side by side with the data scientists say, if you tell me that on Thanksgiving weekend that my flight's going to be on time out of New York, like I'm going to tell you you're wrong. The model's wrong.
Yeah.
And they can put that in as a hypothesis and then say, okay, the model does not predict it. I don't trust it. So this is really about trust and confidence in the model.
And is that, is this kind of signaling to the data scientist, or is this creating signals that get fed into AutoML or some kind of automation?
This particular thing, the assertion does not influence the training.
Got it.
It only tells you whether or not the model that was trained, whether it passes sanity check.
Yeah.
But it's not going to change it to make these true, because sometimes you make bad assumptions based on what you think that actually are not true when the data finds the pattern. The algorithm finds a pattern, it's not true.
Got it.
But it's a good way to test. And there's plenty that you can do to kind of influence that prediction. And so I would hit train here. And each time I hit train, and I think maybe I went by this kind of fast, you can see you can turn on the algorithms you want to test against. Code your own if you want. I've got one of these on right now. And it tracks the experiments so that I cannot, if I'm doing this in a notebook and I hit run and then I change something and I hit run and I cannot remember which exact combination led to that exact AUC. But here it's all tracked for you. So this is one of the real benefits of using a platform like this over just notebook iteration. And everybody can see what was done and why you think the best model is the best model.
Get your hyperparameters out of your file names.
Yes. I mean, we can definitely annotate here, but who wants to go through that? It's brutal. And so when I look at the results for an individual algorithm, here's where all this time saving comes in, right? I don't have to code up a chart for variable importance or partial dependence or subpop, individual predictions, right? ICE and SHAP scores, things like that. What if analysis? Go on.
You mentioned SHAP scores. You also mentioned in the AutoML process some ability to select model categories based on degree of interpretability.
Hmm.
Are there any other features oriented around the idea of interpretability or explainability?
Yeah, I think a couple I'll show you. One is actually this one that I happened to click on. This is a what if analysis. So I can say, okay, but maybe if I'm using a neural network, maybe what happens inside the machine is crazy. I don't really understand how I can get from inputs to a prediction. But here I can go in and I can manually create an observation.
Oh, wow.
And this can look like a segment, like a profile in my data. And I can save that profile and then kind of do the car dealership comparator.
Hmm.
These types of different flights are going to be delayed for these different reasons. And here is where you see, well, this is ICE, not Shapley values, but we could switch it. You can see the individual prediction, what was important to this prediction. So this really helps with that explainability. Also in the confusion matrix, it's quite common to put costs in there. Like the cost of a false positive is different than the business cost of a false negative. And when you're doing healthcare or criminal justice and other like really high stakes predictions, even for airports, right? There's different costs. So changing my conservativeness of the threshold changes those costs, changes those outcomes.
Got it.
So I mean, so many goodies. I could spend an hour just talking about visual machine learning in Dataiku.
Well, we spent a bit of time talking about building models, and as you mentioned, there's a lot more that we could cover. But let's say we've built the model. How do you actually deploy it and deliver it out to your users or systems?
Yeah. Well, what do you do with it? That's the question. And that's usually where most projects fail is, okay, we have it. It has good accuracy, but maybe you throw it over the wall to IT and they recode it 6 months later. And by then it's out of date, right? So we have to fix that. And we can deliver through Dataiku a number of ways. One is batch jobs, right? Like the oldie but goodie. How do I deliver this into an automation scenario where when some trigger happens, this model gets run, it scores new data, and then that data lands somewhere.
Mm-hmm.
Another is API deployment. And so there's also dashboards and applications. We'll talk about that. But once I have an algorithm I like, I can do a few things. First of all, I can export it for use in some other tool. But I don't want to forget to talk about model documentation because this is probably the most painful part of deploying a model is somebody has to go back and write down everything that was done. And then when it changes, they have to do it again. And especially for regulated industries. Here, you just export it. You can make it in your own template instead of ours if you like. But you get something like this. What do we do with our data? What was our hyperparameter search and our validation? What did the lift look like? So all those results I just showed you in the design, it's all documented.
And when you're talking about lift, for example, presumably you've specified a baseline somewhere in the system?
Yeah, this is going to be just against kind of like random.
Okay.
Right. What's the lift across random? If I had a baseline, I could set that up, but it probably wouldn't be in this area.
Okay. Okay.
Yeah. But all kinds of things. This is one of the best things, just to remember what you've done and archive this off with the model as an artifact. So if I go back, I can deploy this model as a new object in my flow. And that kind of puts that stake in the ground and says, this is the model that we want to productionalize. And if we go back to the flow, you can see that's kind of how we got this little green object. Mm-hmm. And so let's say we have another branch that brings in new data and wants to score it through that model like this, score it through that model and give me some results with a prediction. Scenarios is that batch scoring. It's like really flexible. We have drift monitoring. Let's see if we have update the model for retraining. You define a trigger. When should this thing run? And when it triggers, what should happen? get the new data, retrain it, check the metrics to make sure that they're correct, push it to production, notify somebody. That would be a typical type of scenario.
And so that's an automated retraining. You mentioned dashboards. How does someone who's managing a model keep an eye on drift and performance fall off, that kind of thing?
Yeah, typically what you do is a combination of things. One is, I mentioned that you can build charts and generate metrics on any of these data sets. So after, here's an example of drift checking. You can set up on the table that's been scored charts, let's say, that maybe plot data drift or plot AUC or performance drift. And when it hits some kind of threshold, it sends up an alert. Okay. Or you can look at views periodically. That would be kind of the automated way to monitor it. And I'll show you in the dashboard how that would show up. But you can also look at the active version, and the data scientist can come in here and look at a model drift view. And it's going to say, okay, looking at the new data that's coming in, let's look at some new data. Let's compare it to the data we trained our model on. And if the machine can tell the difference between the old data and the new data, then you may have a problem. Yeah. And in this case, we're going to see that there was drift because we trained this data on 2018-19 airport data, and 2020 was a big mess compared to those years. And you'll see the 2020 data does not look like 2019 flight data, which is expected.
Yeah.
So in a second, we'll see this comparison. But yeah, the dashboards, let me actually, I don't know if I want to train this model right now. I may bail out here on this. It's gonna finish the second after I click away, but I don't know if any of these dashboards are populated. I may have some errors here, but almost anything you've seen, I can publish to a dashboard.
Okay.
And so I can check the flights in the air. I can look at the metrics for the tracking. As you see here, deployed model. These are the flights in the air over New York.
Okay.
Model summary. And then let's see if there's some errors here. Yeah, I figured. I don't think they're running right now. I don't think this is actually running right now.
Got it.
But lots of ability to set these up. Yeah.
Yep. Awesome.
And then if you have a second, there's one last thing I want to mention beyond dashboards, which is just the idea of wrapping this into a business application, that an analyst who would never want to see this in a million years, never want to see this, just wants an answer. Mm-hmm. Do you want to see the application?
Let's pull it up. Yeah.
Okay. Based on that flow, we built a little app that works like this. All the analysts would see is this.
Okay.
Okay. And I'd say I have an Excel spreadsheet, has some flights in it. Say I work at JFK.
Yep.
I drag that in. I hit run. It goes through and it does all that pipeline stuff. It spits out a report and a dashboard, the downloadable data, and then the dashboard. And the dashboard just answers my questions of the ones that I gave it, which ones are likeliest to be delayed. Go over here and scroll down a bit. Saturday versus Sunday of Thanksgiving weekend. And which cities are at risk?
Does every flow automatically get one of these applications?
You build it. If this is the right way to serve the insights, you build this.
Okay.
And the nice thing is you don't have to be a coder to build this. We do have web apps that if you know Python, Dash or R Shiny, you can build one. But these are really just kind of analyst friendly. Mm-hmm.
Interface to the flows.
Yeah, it really just abstracts away all the complexity of the flow so that somebody who's just an analyst and wants answers fast and doesn't want to mess with scenarios or data sets, just uses the tools they're comfortable with.
Awesome.
Yeah.
Well, Christina, thanks so much for running us
Yeah.
through Dataiku. Choose your pronunciation. Great to see a bit of the platform.
Yeah. Thanks for having me.
Thank you.